Hi, in this video let's discuss about the lift force. Now, what's exactly the lift force? Now we know that the lift force is a force which is perpendicular to the direction of the wind, isn't it? Now, but the question is, what exactly is the reason of this force? Now, as you can imagine, say for example, let's imagine this is the flow direction of wind. Now let's imagine it is at 0 degrees to that of the blade element. Now when we say 0 degrees, that angle is the angle of the wind to that of the blade chord. So let's imagine it to be 0 degrees. Now you can imagine that the velocity of the particles which are above the blade and the velocity of the particles which are below the blade are equal, isn't it? Because they have to travel the same distance and at the same time. So the velocity would be equal, so naturally there won't be any pressure difference. So there won't be any force because pressure is equal, so it's the blade is in equilibrium, isn't it? So it won't really experience any force, lift force. But what exactly happens is when we change the angle of the blade, say the second diagram right here. Now when we change the angle of the blade, what actually happens is the particles which are below the blade travel lesser distance, but the particles which are above the blade has to travel more distance, but the time taken is equal. So naturally the velocity of the particles which are above the blade has to be more. So as the velocity is more, naturally the pressure is less, because it's a Bernoulli's theorem, it's a law that as the velocity increases, the pressure has to be decreased. So just imagine that the pressure in the above the blade is lower as compared to the pressure below the blade. Now as we know that the area wouldn't be really equal, but you can consider it to be equal. So the difference in pressure causes force, because as we know that pressure is nothing but force upon area, isn't it? So if the areas are equal, naturally there has to be a force. Now the force which is from below is more because pressure is more, isn't it? And the force from above is low because pressure is low, because velocity is more, isn't it? So that is the reason that this blade would experience a force from below, which will cause the blade to move in this perpendicular direction, which we call as lift force. So essentially what happens is, as we keep on changing the angle of attack, as we keep on changing the angle of blade, the lift force will increase up till a certain point, right? We don't have a diagram here, but as you can see from this data that at 7-8 degrees it has a very good lift force, and suddenly it decreases at rate of knots, isn't it? So that is the reason the lift force is so right. So there is a point, you know what I mean, there is a point around say 11 degrees, or 11 degrees, where this phenomena happens, this phenomena right here. Now what actually happens is the flow of the air is not in contact. There is a particular angle which we call a stall angle. This is a stall angle right here. So in this case it should be around say 11 degrees. Now if you see at 11 degrees, suddenly the angle of the coefficient of lift decreases. That's purely because the particle of air aren't in contact with the blade. So that stall angle is a dangerous angle, because suddenly there would be no lift and there would be the lift to drag coefficient would be poor and the blade may experience a negative power, so we have to be very careful about that angle. Now having said this, now let's look how exactly the blade element would experience the force, lift force. Now in this triangle, as we can clearly see, we have a relative velocity, right? Now this angle phi, which is the angle of inclination, is the function of the magnitude of wind velocity and the linear velocity of the blade. Now this phi would keep on changing because the magnitude of wind is random in nature, so accordingly we will change the pitch anyways, and we will try to keep our alpha at 7 degrees because it has the best lift to drag ratio, right? Now imagine as we discussed earlier, the lift force would be in this direction, right? It would be perpendicular to that of the velocity of the wind, which is relative velocity in our case. So this lift force is nothing but, as we said, that as we know that force is nothing but half times the density. Now this density is the density of the fluid and the velocity square. Now when we say velocity square, it is the relative velocity. Now since this is a wind turbine, we have calculated this, but if it's an airplane, then it's the relative velocity between the wind and the airplane would be quite higher, isn't it? Anyways, so right here, and then we multiply it by area, which is our chord, multiplied by the width. It's dr, but it's actually p, isn't it, right here? And here comes the phenomena where this is where coefficient of lift comes in picture. Now as we can see, as the angle of attack changes, the lift changes, because it's basically, technically, if you see, it's nothing but the change in pressure, the change in the pressure of the blade on the upper side, I mean the difference, and the lower side. So as the difference increases, naturally the lift force has to increase up till a certain point, up till like say it reaches this 11 degrees where it will stall. That means it would come to this phenomena where the particles of the air won't really be in contact and the lift force will drastically reduce. We don't want that to happen anyways. So this is the concept behind lift force. Now in next video, what we'll do is we'll calculate the force. Now force, we'll calculate the tangential force, because that is the force which will give us power. Now what is tangential force? Now, essentially tangential force is the force which is in this direction. I mean the direction of the linear velocity of the blade. So this is the direction which is our interest, isn't it? Because we are interested in the tangential force. So in the next video we'll discuss about the force which is being experienced with the tangential force, which is really important, which is the function of lift and drag force. We'll derive it, and then we'll derive the power. I'll show you a spreadsheet in which we can clearly see the different parameters of the wind turbine, in which we will calculate all the forces and coefficient of power and stuff. So for this video, we'll end this now. We'll end it here, and see you in the next video then. See you then. Bye bye.